Each winter, more than 150 million motorists in the United States and Canada are threatened with snow and ice-covered roads. They expect these hazards, but they also expect to have safe conditions restored as soon as possible. We have a highly mobile society, and people who rely on motor vehicles for transportation won't tolerate poor winter maintenance that leaves road conditions hazardous for long periods. Motorists don't expect June driving conditions in January, as salt critics often charge, but they do expect reasonably safe driving conditions as soon as possible. Providing good road conditions in winter is a constant challenge to street and highway maintenance crews. Snow fighting is tough and demanding. Snow fighters must be ready to go into action day or night on short notice and work long, tiring hours. But willingness to work long and hard is not enough. Snow fighters also must have the right equipment and use efficient economic methods. During a storm, the object is to clear the roads as quickly as possible with the least effort and the least cost to make roads safe again. Most snow fighters agree that sound preparation, good plowing, and sensible salting are the best snow fighting tactics. But some agencies still use large amounts of abrasives, such as sand and cinders, instead of using straight salt, partly because they believe abrasives are economical. But abrasives can't cause melting, and therefore can't help remove snow and ice. They only provide temporary traction. Initially, abrasives may cost less than salt, but when the costs of mixing in salt to prevent freeze-up, labor, and equipment are included, the initial cost difference narrows considerably. Add to that the cost of spring cleanup, and abrasives usually end up costing more than salt. When all these factors are considered, salt proves less expensive, and it clears the roads. Although salt's melting action slows down at colder temperatures, the addition of a small amount of liquid calcium chloride to the salt just before or as it is spread will make the salt work faster and extend its range of quick effectiveness. This increased melting action makes it unnecessary to switch to abrasives in colder temperatures. Some agencies use abrasives merely because they are more visible and the public can see that the roads have been treated. Though salt isn't as visible on a road, the melting snow and ice and patches of bare pavement will quickly indicate that the roads have been salted. It's important to get salt down early in a storm. This fights snow from the bottom up. A salt brine quickly forms between the snow and the road surface, preventing the snow and ice from bonding to pavement, thus making snow removal easier. With ice, the brine not only helps melt the ice, but helps break it up as vehicle wheels pass over it. High-pressure weather systems usually move in after a snowfall, and most often that means temperatures will drop sharply. Thus, any accumulated ice or hardpack will be more difficult to remove, even with salt. Once salt brine gets between snow or ice and the pavement, plowing can quickly provide a bare road surface. If hardpack is allowed to form without the use of salt, the hardpack will bond to the pavement. Removing it by mechanical plowing will be extremely difficult, sometimes impossible. Salt has definite advantages over abrasives. Salt is ready for application when it's delivered. Abrasives are not. Some salt must be added and mixed to prevent freeze-up of the abrasive stockpile. The amount ranges from just enough to prevent stockpile freeze-up to amounts of salt that would actually do the job alone. without the abrasives in the mix. Salt melts snow and ice. Abrasives don't. They provide only temporary traction. Any melting that occurs with abrasives is caused by the added salt, not by the abrasives. Some users of abrasives also believe that because abrasives are dark, they absorb solar radiation and therefore do some melting. There is very little solar heat to be absorbed during a storm. Some does occur afterward when the sun comes out, or after late winter storms when temperatures often rise. But temperatures usually drop sharply after most winter storms. Salt goes farther. Because abrasives can't remove ice and snow, 2 to 3 times more abrasives than salt, as much as 1,500 to 1,800 pounds per 2-lane mile, must be used just to provide temporary traction. On the other hand, salt provides traction while it begins the melting process, and a lot less needs to be spread. Salt requires less equipment. Because it takes less salt to treat a road, less equipment, less labor, less time are required to cover a specific distance than with abrasives. Abrasives remain on roads long after their use. Salt does not. Abrasives kicked up by vehicle wheels often cause pitting of windshields. They also chip paint on the front and side of cars and trucks. Salt splashed on vehicles is easily washed off. Washing a vehicle frequently can help protect it from corrosion. Abrasive damage is immediately permanent. Abrasive material that remains on roads after snow and ice are cleared away is sometimes responsible for skidding accidents. The abrasive particles have the effect of tiny ball bearings or marbles. They're especially hazardous to motorcycle and bicycle riders. Leftover abrasives also create dust and are unsightly. A major expense with abrasives often overlooked is cleanup. Some agencies sweep up abrasives soon after a storm, but most wait until spring when they use mechanical sweepers and remove abrasives from gutters, shoulders, and storm drains. Removal of abrasives from streets is necessary to control dust, as well as to avoid damage. Although it may not be necessary to clean up abrasives on rural roads each year, they will eventually have to be cleaned up. Otherwise, the buildup of abrasives will interfere with proper drainage and cause damaging runoff that erodes soil and washes out guardrails. Abrasives buildup also can cause ponding of water that will damage roads and shoulders. Salt requires no cleanup and results in no such damage. The man-hours saved by mechanical sweeping and manual cleanup can be applied to other necessary projects. Another reason to clean up abrasives is to prevent silting of lakes and streams. This is just as important as proper drainage of salt runoff to prevent damage to water supplies or vegetation. There should be no environmental problems with salt if there's good storage, calibration of spreaders, and proper salt application. Lush and healthy vegetation along hundreds of thousands of miles of streets and highways that are treated with salt in winter offers proof that using salt sensibly and storing it properly leaves the surrounding environment unharmed. Vehicle corrosion appears to be the primary concern of salt critics. Salt can speed up corrosion, but the chances of a vehicle rusting can be reduced considerably by the owner's thoughtful care, by touching up nicks and scratches before winter, by waxing the car or truck, by washing it regularly throughout the winter. This is important even now when vehicle manufacturers, particularly in the U.S. and Canada, are doing so much at time of production to eliminate the corrosion problem. In recent years, automakers have made great efforts to minimize corrosion by better design, by using better materials, zinc-coated steel, plastics, and other protective coatings and processes, and their efforts are continuing. North American automakers, in particular, are now offering warranties against rust penetration for as long as 5 years and 50,000 miles. There are also good commercial anti-corrosion processes available to owners after they buy their vehicles. But even with built-in protection, the owner should give his vehicle the necessary care to help prevent corrosion. It's just common sense to protect a car from a harsh winter environment. Protecting people from the hazardous winter road environment is the job of the street and highway maintenance departments. They need salt to effectively combat snow and ice. In this city, they believe in using salt. Unfortunately, they ran out of it just before this late winter storm. Unsalted streets are unsafe streets. Unsalted streets also waste energy. Research has shown that slippery streets covered with snow or ice waste fuel. The published results concluded that the amount of gasoline that a vehicle engine consumes is directly related to the forces that it has to overcome. The condition for optimum fuel consumption is well-inflated, good tires operating on a dry, high-type pavement. Ice and snow cause vehicle wheel slippage, which increases fuel consumption. Also, as snow builds up, more energy is required to push the snow down so the wheels can move forward. Traffic over the snow creates an uneven driving surface, and when vehicle wheels continuously have to go over these bumps and in and out of these depressions, gas mileage is reduced even more. The study showed that passenger car fuel consumption increases 45 to 60% on just 2 inches of snow lying on top of hardpack. Tests conducted in Pennsylvania and elsewhere demonstrated that when all factors were considered, salt was less expensive and provided a higher level of service with clear roads. With abrasives, the roads were never cleared until there was natural melting by solar radiation and rising temperatures. Winter maintenance agencies using abrasives are invited to conduct their own tests to determine the effectiveness and economy of using straight salt, mostly in conjunction with plowing or snow and ice control. A special Salt Institute form is available for making a comparative cost analysis of salt and abrasives. Our field staff will help any agency make the evaluation. The icing salt should not present problems. The technology to avoid them is available. Where problems do exist, they are easily solved and eliminated. Sensible salting. That's what provides the most efficient winter maintenance at the least cost. Salt saves. It saves time, equipment, manpower. It saves fuel, saves money, and saves lives.